Hello, welcome to Grade 10 Mathematics Unit 6, which is surface area and volume of composite solid figures. Here we'll try to see these points. What's a composite solid figures and how we can compute surface area and the volume of composite solid figures. So we'll try to see different composite solid figures and how we can evaluate the surface area and the volume of those composite solid figures. So a composite solid figure is a solid figure which is made up of two or more solid figures. So identify each components of a given shape before we compute the volume or the surface area. We'll identify each component of a shape. Break the figure into recognizable solids such as cube, cylinder, cone, maybe sphere, a pyramid, and prisms. So we'll try to break a given composite solid figure into recognizable solids, which are listed some of these here. Treat each solid separately before combining the result. If it is about surface area, we'll try to compute the surface area of each separable or recognizable solids individually. Then after, either we'll add or subtract depending on a solid figure. So when we add or subtract volume of composite solid figures, so we'll add volumes when combining shapes. When we combine two or more solid figures, we'll add the volume of each solid figures. Like if cylinder is combined with hemisphere, we'll add a volume of a cylinder and the hemisphere. And subtract when one solid is removed from another. In case of volume, we'll subtract when one solid is removed from another. Example, a hole drilled through. When some hole is drilled out from the other, we'll subtract the volume of that. And also, when we compute a surface area, it needs great attention. Surface area is thicker than a volume. It's more complicated than the volume. The volume, it's two cases. One, when we combine two different solid figures, we'll add the volume. When some part of a given solid figure is removed, we'll subtract the volume. But in case of surface area, it's more complicated than the volume. So it needs great attention. Exclude shared or hidden faces. When two solid figures share the same face, we'll subtract, we'll exclude. Only included surfaces that are visible on the outside of the composite shapes must be considered. So having these ideas, we'll try to compute a volume and surface area of composite solid figures. Now, let's look this solid figure. This one is a solid figure which is composite between two. The one, it is rectangular, prism, and also a circular cylinder is drilled out through this rectangular prism. So how we can compute the volume and surface area of this composite solid figure? Now look, to find the volume of this composite solid figure, since some part of a prism is drilled out, which is a cylinder, so the volume of the remaining solid equals to a volume of a prism minus the volume of a cylinder. So a volume of a remaining solid figure V equals to volume of a prism, let's say denoted by Vp, minus a volume of a cylinder, which is equal to what is volume of right rectangular prism. A volume of right rectangular prism is area of base times height, and the dimensions are given. The rectangular prism measures 10 by 6 by 8 centimeter. So the volume is a product of these dimensions. That is 10 centimeter times 6 centimeter times 8 centimeter minus what is volume of a cylinder. A volume of a cylinder is area of base times height. Area of base times height. So the area of a base is pi r square, then times the height. The height of a cylinder is equal to the height of a prism. The longest side of a prism, which is 10 centimeter. From the three dimensions, 10 by 6 by 8, the longest side, that is 10 centimeter. So the height is equal to 10. So the volume of a prism is equal to 10 times 6 times 8. That is 480. The radius of 10 times 6 times 8 centimeter equals to 480 centimeter cube minus, then the radius of a cylindrical hole is 2 centimeter. So r squared, that is 4, then times 10, 40 pi centimeter cube. So we can put in terms of pi, so 480 minus 40 pi centimeter cube is the volume of the remaining composite solid figure. And now, how we can find the total surface area? The total surface area of this composite solid figure equals to the lateral surface area of a prism, which is the surface area of the outer region. That is lateral surface area of a prism, then plus there is also region which is drilled out. So the lateral surface area of a cylinder, then plus we have also another surface area which is called upper and lower base area. So here we have only this shaded region because this part is drilled out. So the area of this shaded region is equal to area of a rectangle minus area of a circle. But we have an identical lower base. So we write twice of area of base. Let AB denotes area of base. So what's area of base? Area of a rectangle minus area of a circle. So to find the total surface area, we need to recall how to find the lateral surface area of a prism. A lateral surface area of right prism is perimeter times height. Then plus the lateral surface area of a cylinder is the same. The perimeter of a cylinder is 2 pi r times h, then plus twice of area of this shaded region. Area of this shaded region is area of a rectangle minus area of a circular region. That is, area of a circle is equal to 8 centimeter times 6 centimeter minus pi r square. Now let's substitute. The total surface area equals to what is perimeter of a prism? It's 8 by 4. So the perimeter of this prism is, this is 8 centimeter, this is 6 centimeter. So what is the perimeter now? It is the sum of these 4 dimensions, 8 plus 6, that is 14, times 2. Or we can add all values. So what is 8 plus 6? 14 times 2 is 28. 28 centimeter times the altitude of a prism is 10 centimeter. Is 10 centimeter plus 2 pi RH, 2 times pi, times the radius is 2 centimeter, times the height is 10 centimeter, then minus Ty self, minus Ty self, 48 centimeter, that is 6 times 8 centimeter pi r square. Since the radius is 4, it is 4 pi centimeter. Now let's simplify these values. So the total surface area AT equals to 280 centimeter square. Then plus 2 pi times 2 times 10. That is 40 pi centimeter square. And here plus 2 into 48 minus 4 pi centimeter square. Therefore, these values are equal to plus 96 centimeter square minus 8 pi centimeter square. So let's combine similar terms now. The total surface area equals to 280 plus 96 centimeter square. That is 376 centimeter square. Then 40 minus 8, that's plus 32 pi centimeter square. Now we can write the answer in terms of pi. 376 plus 32 pi centimeter square is the total surface area. So from this result, we can understand that finding the surface area is some bit more complex than finding the volume. So it needs an attention. So do more exercises how to compute the surface area. Example 2, a cylinder of base 4 centimeter and a height 10 centimeter has a square pyramid base 8 centimeter attached to its top. The pyramid height is 6 centimeter. Look here, this solid figure is composed of two different solid figures. The one is cylinder, the other one is a pyramid. So how we can find the volume? So finding the volume is now very easy. It's like combining two different solid figures. So combining two solid figures to find the volume, it's simply adding the volume of the two solid figures now. So the volume equals to volume of a cylinder plus volume of a pyramid. Now let's find the volume of each. How we can find the volume of a cylinder? A volume of a cylinder is equal to base area times height. Base area of a cylinder is pi r square times h plus how we can find the volume of right regular pyramid. It's 1 over 3 area of base times height. So now it's very simple. We can substitute the values. What is the radius of the cylinder? It's 4 centimeter. So 4 centimeter, the whole square, then times pi times, and what is the height of a cylinder? The height of a cylinder is equal to 10 centimeter. The height of a cylinder is 10 centimeter. So times 10 centimeter, then plus area of a base of a pyramid. A volume of a pyramid is 1 over 3 base times height. 1 over 3 times what is the base of a pyramid. So it says a square pyramid with base 8 centimeter. A solid figure which is attached at the top of this cylinder has a base which is square pyramid with 8 centimeter side lengths. So base area is 8 centimeter the whole square, since it is a square, times what is the height? A height of a pyramid is a perpendicular distance from the vertex of a pyramid to base of a pyramid is given, which is 6 centimeter times 6 centimeter. Now V equals to 4 the whole square, 16 times 10. 16 times 10, 160 times pi. 160 pi centimeter cube plus 8 the whole square, 64, or we can cancel here. Before combining, we can simplify. So 6 divided by 3 is 2. 8 the whole square is 64. So 64 times 2 is 128 centimeter cube. Good. So the volume of this composite solid figure is equal to now 160 pi plus 128 centimeter cube. So we can leave the volume of this solid figure in terms of pi. Example 3. A decorated candle is made by combining two solid figures. The base of a candle is a cylinder. You can observe here as a decorated candle, which is made by combining two solid figures. The one is a cylinder, which is the bottom one. The top looks like a cone. So the base of a candle is a cylinder with base radius 3 centimeter. And the height of this, what we call a cylinder, is 10 centimeter. And the top of the candle is shaped like a cone with the same radius. The radius of a cylinder is 3 centimeter. So the cone has also the same radius, which is 3 centimeter. And the height perpendicular distance from the top of the candle to base of the candle, which is 5 centimeter. So what is the volume of the candle? And if the wax used to make the candle costs bear 2 per centimeter cube, what is the total cost of the wax used to make this decorated candle? So how we can find now the volume of the candle, since it is made by combining two solid figures, a volume of the cylindrical part plus a volume of a cone. So a volume of a cylinder is pi r square times h plus a volume of a cone is 1 over 3 area of base, that's pi r square, times the height h. Now, what is the radius of a base of this candle? The radius is 3 centimeter. So 3 square is 9 times the height, that's 10. So 90 pi centimeter cube plus 1 over 3 pi times the radius of the cone is also the same as the radius of a cylinder, which is 3 centimeter. So 3 the whole square is 9 times what is the height of the cone part? It's 5 centimeter cube. It's 5 centimeter cube, the unit. So we can simplify this. If we divide 9 by 3, it is 3 times 5, 15. So 15 plus 90 equals to 105 pi centimeter cube. This is the volume of the candle. And we are asked to determine the total cost of the wax used to make this decorated candle. If bear 2 costs per centimeter cube. So what is the total cost? Total cost equals to volume times 2 bear per centimeter cube. So what is the volume in centimeter cube? 105 pi centimeter cube times 2 bar per centimeter cube. So this unit will be cancelled by this one. It is 210 pi bar, but it's better to write pi, the approximate value now. 210 times 3.14. Let's try to approximate. So the total cost equals to, so the total cost of a wax used to make this decorated candle is 659.4 bar. Example 4, a lead bar of 15 centimeter, length, width is 8 centimeter and thickness 5 centimeter is melted down and made in 5 equal spherical ornaments. Find the radius of each ornament. Here, maybe we can like a lead bar 15 by 8 by 5 centimeter is melted down. When one object is like melted down, it may change its like shape, but still the volume of that object is still constant or the same. So after this rectangular bar is melted down into 5 equal spherical ornaments. So the volume of rectangular bar equals to the volume of these 5 spherical ornaments. So let's start by this. Volume of rectangular bar equals to these 5 equal spherical ornaments. 5 times volume of each ornaments which have a spherical shape, each sphere. So what is the volume of a rectangular bar? The volume of a rectangular bar is length times width times thickness. So it is 15 centimeter times 8 centimeter times 5 centimeter, which is equal to 5 times volume of each sphere. Now, before multiplying, we can divide both sides by 5. Now what's 15 times 8, which is 120 centimeter cube equals to volume of each sphere. So what's our objective? To determine the radius of each spherical ornament. And what is a volume of a spherical ornament? A volume of this spherical ornament is given by 4/3 pi r cube. So now we'll try to determine what is the radius. This is very simple equation. So if we make it a crisscross, 120 centimeter cube times 3/4 pi equals to r cube. If we simplify this by 4, this one is 30 times 3, 90. So r cube equals to 90 centimeter cube over pi. Now the radius r equals to, taking the cube root to both sides, the cube root of 90 over pi centimeter. It's better to put in terms of pi, because to find the cube root of 90 over pi, since it is not a perfect cube number, it's difficult to approximate in decimal form. So it's better to put as it is. Okay, so this is exercise for you, another very interesting solid figure, which is made by attaching a hemisphere on the top of a cylinder. This one is a hemisphere which is attached on the top of a cylinder. The radius of both the cylinder and the hemisphere is 5 centimeter, and the height of a cylinder is 10 centimeter. What is the total surface area of the solid and what is the volume? So volume is volume of cylinder plus volume of a hemisphere, half of a sphere. And the total surface area of this is the surface area of the outer parts, which are the lateral surface area of a cylinder, the area of the hemisphere, and also there is another area which is the base area of this cylinder. Then do these values and check that the total surface area is 175 pi centimeter square and the volume is 1000 over 3 pi centimeter cube. Example 2, a solid made by placing a square pyramid on the top of cube with edge 5 centimeter. If the height of a pyramid is 6 centimeter, what is the volume? There is a cube, then on the top a square pyramid is attached. So the height of a pyramid is 6 centimeter and the cube with edge 5 centimeter, what is the total volume? Compute using the ideas what we have discussed and check that the answer is 275 centimeter cube. Example 3, a cone is placed on the top of a hemisphere. There is a hemisphere. So on the hemisphere, if a cone is placed on the top, if both the cone and the hemisphere have a radius 6 centimeter and the cone's height is 10 centimeter, what is the volume? The volume obtained by combining two solid figures is equal to the sum of a volume of each solid figures. So compute these values and check. The answer is 432 pi centimeter cube. Exercise 4. A tank is shaped like a rectangular prism. A tank is shaped in the form of rectangular prism with half a cylinder on the top. The tank is shaped like rectangular prism, then with half top a cylinder. A prism is 8 centimeter long, 5 centimeter width and 3 centimeter height. Half the cylinder has a radius of 2 centimeter. What is the total volume? Here the dimension of a prism is given, the dimension of a cylinder, radius 2 centimeter. And half of the tank is a cylinder. So what is the height of a cylinder? It's equal to the height of a prism. So having these values, compute the volume of this tank and check the answer is 96 plus 16 pi centimeter cube. So every values are in centimeter cube. So to determine now the total volume, try to sketch roughly what looks like the tank. If you try to sketch the tank, it's very easy to compute the volume, even the surface area. Sketch or try to figure out these statements to understand easily how to compute the volume and the surface area. So in general, we have tried to cover a composite solid figure is a solid figure which is made up of two or more solid figures. So how we can compute the surface area and the volume of these composite solid figures? It's better to break the figure into recognizable solids like a cube, cylinder, cone, sphere, a prism, and a pyramid, which are familiar solid figures, and add volume when combining two or more solid figures, and subtract volume when some part of a given solid figure is taken out from a given solid figure. And to compute the surface area, it needs more attention than the volume. So it needs more practice. Practice by doing all these exercises, what I'm lifting for you. This is all about the lesson. See you next time. Thank you.